Hello students, and welcome to the series of videos on a graphical approach to solving differential equations. So first, let's take a look at kind of a motivating example on why we need to use a graphical approach at all. So in this example it says here, find a function f of x equals y that satisfy the following equation, differential equation. Okay. So we will try what we always do, which is separation of variables. Okay, so this is y prime is just dy over dx, which is equal to 2x plus y, and then multiply both sides by dx, 2x plus y dx, quantity, and then divide both sides by this quantity, which is dy over 2x plus y, okay, equals dx. Now, this presents a bit of a problem for us because the variables are not easy to separate. It turns out you probably can separate these variables, but the point is, at this point, it's difficult to be able to separate those two variables. So it's not easy to separate those two variables. Now, so that's kind of a motivating example here as to why we need to take a graphical approach at this. We will learn methods for dealing with these types of differential equations later, but for now, let's take a simpler approach, which is the graphical approach. So, welcome to slope fields. And slope field is basically a graph where the coordinates, each of the coordinates show the slope of the function. Okay, so it's a graph where each of the coordinates show the slope of the function. Actually, it's the instantaneous slope. Okay, so let me show you how this works with our example that we had up there, which was dy dx equals 2x plus y. Okay, so I'm going to start by making some xy axes, and then we'll start graphing this. Okay, so those are the axes, and then I'll make a little x, y, dy dx table. Okay. And dy dx is equal to 2x plus y. So when x is 0 and y is 0, dy dx is 2 times 0 plus 0, so that's also 0. And that means at the origin, the slope is flat. It's 0. And we'll draw a little line segment there to show that. Let's try 1, 1. Okay. So when x is 1, y is 1, the slope is going to be 2 times 1 plus 1, so that's 3. So if we go to 1, 1, and we make a slope of approximately 3. Okay. And let's try a couple more. Let's try, let's see. And I always like to go in sort of a square pattern around the origin. So let's try 0, 1. So in this case, x is 0, y is 1, so the slope is 1. So at 0, 1, the slope looks approximately like this. Okay. And I'm just going to go ahead and continue, fill out my table, and fill out the rest of this picture. Okay. So at 0, negative 1, x is 0, y is negative 1, so the slope is negative 1. And as you do this, you will start to see some patterns form. And one of the patterns is that on the y-axis, when x is equal to 0, dy dx is equal to y. So I'll say when x is equal to 0, dy dx is equal to y. Which means along this vertical axis here, whatever number is, whatever the y value is, that's the slope, because x is going to be 0. So we can actually go along the vertical axis here and figure out all the slopes. For example, at 0, 2, the slope is going to be 2. At 0, 3, the slope is going to be 3. 0, 4. So as I go up here, it gets steeper. And as I go down this way, it gets steeper as well, but in the negative direction. And so these are some of the patterns that you can see start to form as you graph this whole thing. Okay, and then I'm going to keep going and just graph. Now let's see here. What if y is equal to 0? Well, if y is equal to 0, not when, okay, y is equal to 0, dy dx is equal to 2x. So for example, when x is equal to 1, the slope is going to be at 1, 0, the slope is going to be 2. Okay, when x is equal to 2, the slope is going to be equal to 4. 1, 2, 3, 4. So as you go this way, it gets much steeper. Okay, and it's going to look almost like it's vertical. And then same thing with the other side. At 1, the slope is going to be -2, then -4, then -6, then -8, and eventually it's going to look so steep that it almost seems vertical. Okay, so these are some of the things that we can follow, and I'm just going to graph a little bit more. And more importantly, the complete picture, which we'll fill out in a little bit more, will give us. This is like a field. Okay, of all solutions. So it's like if you were to take many solutions to the differential equation and you graph them, they would represent this field. Okay, I'll show you what I mean in a minute. Okay. So I'm going to end this video right here, and kind of the big picture that you need to take away from this is that solving differential equations sometimes is very difficult, and we cannot do it algebraically, but we can get the process going by having a graphical approach, which is represented by a slope field. Okay. I'll end this video there. We'll pick up the next video with how to go from slope field to a potential solution.